All right, this is Pre-Calculus B, Unit 3, Lesson 5. We're going to continue our work on the law of sines and the law of cosines, solving non-right triangles. This is our last case. We're going to solve a side-side-side triangle. Okay, you recall the law of sines. It says sine A over A equals sine B over B equals sine C over C, where like letter pairs are opposite angles and sides. The law of cosines looks like the Pythagorean theorem. A squared equals B squared plus C squared minus 2BC cosine A. Think of it instead as bookends. Any side squared is equal to the other two sides squared and added, minus 2 times the product of the other two sides times the cosine of the angle between them. Okay? Rather than memorizing all three forms, switching the letters around and stuff like that, it's easier to think of in relative positions. Okay, so let's do our side-side-side case here. So we're given a triangle in which I know all three of the sides, but none of the angles. A, B, C. Okay. So here we go. And there. Okay. So lowercase a is across from uppercase A, lowercase b is across from uppercase B, and lowercase c is across from uppercase C. Make sure that your c's are obviously different sizes. Otherwise it can get a little confusing because lowercase c looks just like an uppercase C. All right. And let's say in this case I know all three sides. So let's say C is 12, A is 10, and B is 14. Okay? And we're looking for angles. Now you recall the rule I gave you to indicate whether or not you could use the law of sines. To use the law of sines, I need a side angle pair. Now because I don't have any angles at all, I can't use the law of sines. But I can use the law of cosines. Now I want to rearrange the law of cosines here. Notice we have a squared equals b squared plus c squared minus 2bc cosine A. I want to rearrange this and solve for cosine A. And I'm going to use that to solve this problem without having to solve it each time. Because a lot of textbooks will have you insert, substitute, and then solve for cosine A. I prefer to solve for cosine A first. So a squared equals b squared plus c squared minus 2bc cosine A. Subtract b squared and c squared, so a squared minus b squared minus c squared equals negative 2bc cosine A. And then divide by negative 2bc cosine A, so a squared minus b squared minus c squared over negative 2bc equals cosine A. And then A equals then the arc cosine of a squared minus b squared minus c squared over negative 2bc. Okay. And we're going to use that form to find A and B and C, etc. Notice the relationship here. A, cap A, lowercase a, right? So an angle is equal to the arc cosine of the opposite side squared minus the other two sides squared and then subtracted, divided by negative 2 times the product of the other two sides. Okay? So in that case then, A is the arc cosine of a squared, 10 squared, minus 12 squared, minus 14 squared, over negative 2 times 12 times 14. Okay, and we can figure that out here. Desmos, oh Desmos. Okay. And make sure we're in degree mode. I believe we are already. Arc cos. You can spell it out in Desmos, or you can use the keyboard app to select cos -1. 10 squared minus 12 squared minus 14 squared, all divided by -2 times 12 times 14. Okay, 44.42 degrees. Okay, and I can do the same thing for B and C. So B, arc cosine. Okay, the V squared, so 14 squared minus 12 squared minus 10 squared, divided by -2 times 12 times 10. Okay, so 12, 10, I'm sorry, 14 squared, 14 squared, 10 squared, let's do it the way it's written, 12 and 10. Probably should have just rewritten it. 12 and 10. Okay. In fact, let's go ahead and do that. This is B. Okay. 78.46. Okay. And now I can do the same thing with C if you want, or we could subtract from 180. So if A is arc cos of 10 squared minus 12 squared minus 14 squared divided by -2 times 12 times 14. Okay, there's A, and then C is equal to 180 minus B minus A. So C is 57.12. Okay, there we go. We've got A, we've got B, we've got C. We have solved the triangle for the remaining 3 facts. Okay, but it really helps, like I said, to solve for cosine A, or just have memorized this other form of the law of cosine. It's just another form.